Hello and welcome to another video tutorial. In this tutorial, I want to show you how we can do a dynamic pivot in Snowflake with multiple aggregate functions. So what I basically mean by that, or what I mean by pivot first of all, is if we have a table like this with 4 columns, city, year, category, and value, basically I want to pivot this category column so the values in the category column become columns themselves, and the values in those columns will come from the value column. So I've got a pivot query up here already written in Snowflake. If I run that, the end result is going to look something like this. We still have a city and a year column, but now we have some new columns made up from the values that were in the categories column. And the numbers here come from the original values column. And for cases where there was more than one value for a city and year and category, the numbers will be added, and you can tell that's being done from this aggregate function. I've chosen sum. I could have chosen max or min or count or a selection of other aggregate functions that Snowflake can do. Another thing to note is I've only picked a few of the values that were in the categories column, so we're only getting new columns at categories BA, AB, AC, and CA. I chose those because those are the ones containing the letter A. So there were other ones like CB and BC. I didn't want those. I only wanted the ones including A. And for this project, what we want to do in this video is we want to be able to do this dynamically. So rather than typing out manually all the values that contain the letter A, we'd like to be able to say where value contains letter A. Also, we've chosen to use the sum function here, and we've only got one aggregate function. For this video, we're going to do a pivot with 2 aggregate functions. So basically, the end result will look like this. If I run this query, we've done a pivot, and we have the same year and city column. We've also got these columns, which look similar to what were before, but now we have the underscore sum after the column name. And we've got those columns again, but underscore count. So say for this example, for 2018 in Christchurch, BA had 2 values, and added together they equal 5. And so we're basically going to set up a SQL script in this video that's going to let you do things like this dynamically. And this video basically follows on from a previous dynamic pivot in Snowflake video, where the concept is we're going to construct this SQL query from a set of strings that will change dynamically. And so if you haven't watched that video, I'll put it in the description below, and it might make this next part easier to understand. So before I move on to how we can construct this query dynamically, I'll go through how it actually works. So it's broken up into 3 parts, which I've called agg1 table, agg2 table, and then there's a select query at the end. So agg1 table does the sum pivot on example table. So you can see it says it sums the value, and then the column names that come out of that pivot are renamed city, year, as they were before, but then also BA sum, AB sum, AC sum, and CA sum. So you know those are summed pivots. Agg2 table is very similar to the first one, but this is the count pivot. So it does the count aggregate function in here, and then the columns get named with the underscore count at the end. The last bit, the select statement, selects all the columns, so year, city, and then the sums and the count columns from agg1 table, the one that was defined first, joined to agg2 table, and they're joined on the year column and the city column. So basically we're going to make this query above from a set of strings using a SQL script. So a SQL script looks like this. We have this part where we execute the script between these $signs. So we use execute immediate to execute the script here. And the script has a declare part where we declare the variables that we're going to use in the script, a begin where we begin the script, and then an end to tell where the scripts end. So I'm going to drag and drop a few things in here which will slowly create this query here. The first thing we want to declare is the table that we're going to be doing the pivot on. So I'll call that table in, set it to be a string, and the default value is just the name of my table within my schema within my example database. The next thing that's important to know for the script is the name of the column that we're going to be pivoting. So for this case, it's my category column. So I've called that pivot column name, set that also to a string with the value category. Also, we need to know the name of the column that's going to give the values in the pivoted columns. So that's my value column. I'm going to assign that to the variable value column name, and that's also a string. Next, we're going to specify the aggregate functions that we're going to be using in our pivots. So for me, that's a sum and a count. So I've called those variables pivot function 1 and pivot function 2. Both are strings, just set to sum and count. The last thing we're going to declare for our script is a selection of columns that we want to be pivoted. So as above, we had all the columns that contain the letter A. I had to type that in manually before, so we want to pass in a query here. So I've used column list in as my variable that has my list of columns I want to pivot, and that's defined as a string, which is the result of this query within the brackets. So this query basically selects the list aggregate of the distinct categories from my table that I'm pivoting, where the category column contains the letter A. And I'll show you what the output of that looks like in a second. For the next part, we'll start working on our actual script between the begin and end part of our statement. And just to start with, we'll use a return function. So we'll return an output at the end of our script, but as we're writing our script, it's quite handy to use a return function just to see what something looks like that we've defined. So if I return column list in and run our script, you can see what column list in looks like. And what we're aiming for with column list in is to have something that looks like this part of the query. And at the moment it's looking pretty close. So we have our list of column names, but you can see we're trying to match this query almost exactly. We need some apostrophes either side of our commas. So to do that, we'll add another line to our script. I'm going to use the regular expression replace function in Snowflake to replace the commas in my string with a comma surrounded by apostrophes. So this is how you use the function. You pass in my string and replace the commas here with this expression. And you can see I've put slashes before some of the apostrophes. That's to let Snowflake know that the comma isn't the start or end of a string, it's just a part of my string. Also at either end of the string, I've added more strings using this. So this appends a string to another string, and at the start I've added an opening bracket and another apostrophe, and at the end an apostrophe and a closing bracket. That is to mimic the start and end of this string here. So now if I pass column selection into the return function, my output looks like this. The next thing that we're going to do now we have our column names is to add the name of the aggregate functions to the end of them. So that's how we're going to start building up this underscore count renaming list and underscore sum renaming list. So I'll add the next two lines in here, and I've called these two variables column labels ag1, column labels ag2, which are basically the column list in that we defined as all our column names containing the letter A, with an underscore and the pivot function on the end of them. So if I return column labels ag1 and that, then we get the underscores on the end. So we've now made the last part of our renaming list, this part. We haven't got the city and the year column yet, and those are the names of the columns that aren't being pivoted. In our input variables, we've only given our script the names of the columns that are being used in the pivot. So to get the ones that aren't, we could either add them as other input variables, which would be a bit more work for the user, or we could add a bit more logic in our SQL script. So basically we want to know, after we've defined which columns are part of our pivot, which ones are left which aren't part of the pivot. So to get a reference list of all of our columns, we can use the columns table in the information schema, which you should have by default in your Snowflake account. In this table is all the names of my databases, schemas, and tables, and the columns within them. So to get the list of columns that aren't in the pivot, I can use a query like this, which selects the columns from the table that I'm pivoting, excluding the category and the value column. So I'm left with city and year, and I've turned those into a list using the listagg function again. Category and value we pass in as variables, so those can be substituted in this part of the query. And if I were to make that query dynamic, it would look like this. So now if I return unpivoted columns equals string, which is just my SQL as a string, I get that same query. Now, because this is just a query to get the column names that I want rather than the actual column names, I still need to execute this query. Do that using these lines here. So in these lines, I first defined a variable called column labels, which is a string and is empty at the moment. Then I've used the execute immediate command to execute the SQL that I've just defined above. And that gets stored in a result set type variable, which you use for storing the results of SQL queries. And then that variable is saved as unpivoted columns. Now for me to be able to use the result of the query, unpivoted columns, in other parts of my SQL script, I have to get the data out using a cursor. So this is how it's done. We set a cursor C for unpivoted columns, that's my result set. Then I open the cursor C and then fetch C into column labels, which is my string variable before, and then close my cursor C. So now if I return column labels, we get the result of the query, which we can use in other parts of the SQL script now. So we now actually have enough information in our SQL script, either from what's been declared by the user up the top or what we've calculated in the script part, to write the first two parts of our final SQL script. So this is the end result that we're aiming for. We have enough information now to write up to here. So I'm going to start building the final SQL script in my query. I'll just add it in here. So you can see I've created another variable called final SQL script, which is a string. And this mimics basically the script that you saw above. So this puts all the different parts we've calculated together into one SQL script. And it's written in a way that you can see I've started writing a string, and whenever I need to substitute a value that we've calculated or declared, I've used this expression to join the strings together. And so if I return final SQL string, it looks like this. And that's quite hard to read in there. I'm just going to hit copy and paste it in here down below. And you can see this is starting to look like our script above here. And the great thing about this is it's all dynamic. So if for example, I want to change my condition or my aggregate function, I might want to do a max instead of a sum. I can just change my pivot function 1 to max. Rerun that. Open this, and you can see that now everything is underscore max and our pivot function is max. So that's working well so far. I'll just change that back to sum for now while we're working on making an exact copy of the query above. Also, one critical part that I forgot to add, if I run this statement again and open it, you can see in the renaming column that's how it should be. We're renaming to city, year, and then our underscore sum columns. If I run it again, let's see if it does it. Now we have year, city. So these have been reversed to the other way around, and that's actually random each time I run it. And it comes from the unpivoted column SQL string. Those are the names of the columns that haven't been pivoted. And so we get year and city from this query here, which queries the columns table, but the order of them at the moment is random. And so the critical thing that I forgot to add, if I preview this, there's an ordinal position column in this table. So that will tell you where the column is from left to right in your table. So what I need to add to my statement here is within group order by ordinal position. So that will make sure when I run my query, my script, that is always city, year. So now we've got that all sorted, we can move on to making the final part of our SQL query that we're trying to make, this part here. So we already have all these column names, we've made those in our SQL script, so we can insert those in there. Where it does get a bit tricky and we need to make a few other strings to add together is this part here with the aliases. So we're joining ag1 table to ag2 table. And ag1 table gets the alias ag1, and ag2 table gets the alias ag2. So when we do the join, on the last line here we have the names of our unpivoted columns, which we do have. It's year and city. And we need to make sure we make it in a way that we have ag1.year equals ag2.year and so on. And for this example, we have 2 unpivoted columns, but we might have more. We might have 3 or 10 or whatever. So this needs to be a line that goes on for however many unpivoted columns we have, setting those columns from each one equal to each other. Another thing we have to make also for our unpivoted columns is, this is quite similar to the last line, but instead of being separated by an and having two parts equal to each other, we just want ag1.year, ag1.city, and that will go on for however many unpivoted columns we have there. So the next bit of SQL that I add will deal with those parts. I'll just add it in here before the final SQL string. So there are quite a few parts to this bit of SQL. The first parts I'll go through are column join and column with alias. Both are strings and both have just been set to an empty string as their starting value. And those two strings will eventually become this part and this part of our query. So column with alias is going to be this part where we just need to make a comma-separated string of our unpivoted columns with ag1 and a dot before each of the unpivoted column names. And then what do I call the other one? Column join is going to be this part. So it's going to be a list of unpivoted columns setting each different alias equal to the other one. And after I define those two empty strings, there's a while loop. And basically this while loop iterates through each part of the column labels string. So column labels, which is the output of this query up here, which gave us city and year in our case, is separated by the comma. And this counter, which is an integer, is going to be the part of the column labels string that we work on for each iteration of the while loop. So for example, it starts off as 1, so we're going to work on part 1 of the column labels, which is city, and then at the end of the while loop, counter increases by 1, so the next run through we're going to be working on part 2, which is year, and it will keep going for however many parts you have to your unpivoted column list until the part does not equal empty. So it will keep going until it gets to the end, basically. And so what the while loop is doing is adding to the strings column join and column with alias. So they're getting longer each time. And so column join is just adding ag1 dot in the name of our column labels part we're working with, and then adding to the string equals ag2 and the same unpivoted column name with an and on the end. So it's going to always add the and on the end, and then for the next loop of the while, it will continue on with the next unpivoted column name. And column with alias is similar, it's a bit simpler. It's just going to add the unpivoted column name, ag1, with a comma at the end. So if we were to return, say, column with alias, we'd get this. And similarly with column join, we get that. So that's close to what we want. The only thing that we have different between this part of our SQL query and this is we don't want this trailing and at the end. And so the way we deal with that is just to remove those last 4 characters from the end. So I'll add a couple of lines here. Column join gets redefined as column join, but with 4 characters removed from the end, and same with column alias, just had that trailing comma, if you notice that. So that just gets 1 character removed from the end. So now we are finally ready to add the last part of our final SQL to the end of the string here. I'll just paste this in so you can see I've added my column with alias and column join, which we just created. And so let's do one more return for final SQL before we get our final answer. And run that. That's looking good. And so the last thing we need to do is just to execute that query and get the output. So I'm going to make one more variable called output, which is a result set, and that's just the result of this final SQL executed. So I can now return output, and because it's a result set that we want to be viewed as a table, we just have to wrap it in this table function. So just do that, and have I missed anything? Don't think so. Run this, and this is what we wanted. That's our final answer. So the great thing about this is I could change up in the declared variables a different table or a different column to pivot or to use as the values, or different aggregate functions. And if you want to be able to do this in a user-defined function, so if you want a function where you can input these 5 variables and you don't have to worry about the rest of the script, because that would be locked away in a user-defined function, you can follow the link to the video that I put in the description that I referenced at the beginning of this video, and that will help you do that. So I hope that's been useful. Any questions, add them to the comments below. Thank you for watching.